Hello, in this presentation I will discuss about the various parameters used in testing of an IC engine. Engine performance parameters. The engine performance is an indication of the degree of success of the engine performs its assigned task, that is the conversion of chemical energy contained in the fuel into the useful mechanical work. The performance of engine is evaluated on the basis of following factors like indicated power, brake power, friction power, mechanical efficiency, thermal efficiency, air fuel ratio, specific consumption of fuel, etc. So the first one is indicated power. The amount of power which is produced inside the cylinder by burning of fuel is known as indicated power, and it is finding by the actual mean effective pressure. So first we have taken in case of 4-stroke engine where number of power stroke per minute will be equal to half of RPM. So we can take small n equals to n by 2 and let PM is the mean effective pressure, L is stroke length, area is cross section of cylinder, n is RPM of engine, and small n is number of power stroke per minute. So work produced by the engine per minute is PM, that is mean effective pressure, into area into length into RPM. So indicated power is basically PLAN upon 60,000 into 2 kilowatt. Now second one is indicated power for 2-stroke engine. Here the number of power stroke per unit will be equal to RPM of crankshaft, that is N equal to capital N. So the indicated power is given by PMLAN upon 60,000 kilowatt. Second is friction power. The amount of power which is wasted in the reducing of friction is come in the category of friction power, and this is the difference between the indicated power and brake power. Now third one is brake power. It is the actual power available at the engine crankshaft for doing useful work. It is also known as engine output power, and it is measured by the dynamometer. It is given by 2 pi nt by 60,000 kilowatt. So it is the actual amount of power which is available for the useful work. Now the efficiencies, first one is mechanical efficiency, which is simply a ratio of brake power to the indicated power, and mechanical efficiency is the indicator of losses due to friction. Second one is thermal efficiency. It is the efficiency of conversion of heat energy produced by the actual combustion of fuel into the power output of the engine. So it is the ratio of work done to the heat supplied simply, and we can write indicated thermal efficiency is equal to indicated power upon heat supplied by fuel, and heat supplied by fuel is given by mass of fuel and the product of calorific value of that fuel. So MF into CV is the heat supplied by the fuel, and IP is the amount of indicated power. So by using this expression we can find indicated thermal efficiency. Similarly, brake thermal efficiency we can find by the expression brake power upon MF into CV, where again MF is mass of fuel and CV is calorific value of that fuel. Third is relative efficiency. It is the ratio of indicated thermal efficiency to air standard efficiency. Then fourth is air standard efficiency. It is the efficiency of thermodynamic cycle of the engine. For petrol engine, it is given by neta air equal to 1 minus 1 upon R to the power gamma minus 1, where R is known as compression ratio and gamma is a constant which is equal to Cp upon CV, and Cp minus Cv equals to R is the Mayer relation. So the value of gamma is 1.4. For diesel engine, efficiency equal to 1 minus 1 upon R to the power gamma minus 1 into rho to the power gamma minus 1 upon gamma into rho minus 1. So this is the expression for diesel engine, and the upper one is the expression for air standard efficiency for petrol engine. Next is volumetric efficiency. It is the indication of measure of the degree to which the engine fills its swept volume. As we know, inside the piston there are two types of volume. One is swept volume and the other one is clearance volume. It is defined as the ratio of mass of air inducted into the engine cylinder during the suction stroke to the mass of air corresponding to the swept volume of the engine at atmospheric pressure and temperature. Or alternatively, we can say it is defined as the ratio of actual volume inhaled during suction to the swept volume of the piston. Next is air fuel ratio. It is the ratio of mass of fuel to the mass of air in the air fuel mixture. Air fuel ratio of the mixture affects the combustion phenomena in that it determines the flame propagation velocity, the heat release in the combustion chamber, the maximum temperature and the completeness of combustion. Next is specific fuel consumption, SFC. It is defined as the amount of fuel consumed by an engine for 1 unit of power production. So SFC is MF upon BP, where BP is brake power. So we can say this brake specific fuel consumption. If here I write IP, that is indicated power, then it is known as indicated specific fuel consumption, ISFC. Fine. Now the numerical problem based on these testing parameters. A gasoline engine works on Otto cycle, means petrol engine. It consumes 8 liters of gasoline per hour. So this is the mass of fuel, and develops power at the rate of 25 kilowatt. It is the amount of power. Specific gravity of gasoline is 0.8 and calorific value is 44,000 kilojoule per kg. Find the indicated thermal efficiency of the engine. So for this indicated thermal efficiency, we can first find the heat supplied or heat input, which is equal to MF into CV. So mass of fuel and calorific value, the product of mass of fuel and calorific value. So 8 into 0.8 upon 60 into 60. By this, this is because the 8 liter of gasoline per hour consumed. So 6.4 upon 3600 we can get. And now power at the input, when we just multiply this term into CV, that is calorific value of fuel, 44,000 kilojoule per kg. Now we can use the expression of indicated thermal efficiency, that which is equal to IP upon heat supplied. So IP, indicated power, is 25 kilowatt and heat supplied is in the form of expression we can put here, and by the calculation we can get 31.96% indicated thermal efficiency. Next question. A diesel engine consumes fuel at a rate of 5.5 gram per second. So it is the mass of fuel consumption and develops a power of 75 kilowatt. So it is amount of power. If the mechanical efficiency is 85%, calculate brake specific fuel consumption and indicated specific fuel consumption, and the lower heating value of fuel is 44 megajoule per kilogram. So for BSFC, kilowatt heat input and kilowatt heat output, we can put here mf into CV upon P, that is output. So BSFC we can get 0.074 into 10 to the power minus 3 kilogram per kilowatt second, and by converting the calorific value, that is 44 megajoule per kilogram, into kilojoule per kg, and by putting in the expression of BSFC, we can get ISFC equal to 2.7676. So these are the two values of brake specific fuel consumption and indicated specific fuel consumption. Third numerical, which is based on 6-cylinder 4-stroke engine gasoline having a bore of 90 mm, means diameter, and a stroke of 100 mm, that is stroke length, and a compression ratio, this is equal to small r 8, and relative efficiency is 60%. When indicating specific fuel consumption is 3009 gram per kilowatt hour, then estimate calorific value and corresponding fuel consumption. Given that mean effective pressure is 8.5 bar and speed is 2500 rpm. So here relative efficiency is 60% given. So first of all we have to find air standard efficiency, which is equal to 1 minus 1 upon r to the power gamma minus 1 in case of petrol engine. So we are just getting 0.5647 or 56% air standard efficiency. Now relative efficiency, which is the ratio of thermal efficiency to the air standard efficiency, so we can get indicated thermal efficiency 0.6 into that air standard efficiency, which is equal to 33%. Now with the expression of indicated thermal efficiency, we can find the value of calorific value of fuel, that is CV, and that equals to 35,417 kilojoule per kg. Now putting this value in the main expression, that is indicated power, which is equal to PLANK upon 60,000. So by putting all the values, the fuel consumption IP is given 67.6 kilowatt, and then fuel consumption we can get IFSC into IP. So IP, indicated power, equals to 20.28 kilogram per hour. That is all about the testing of IC engines.